In this video, we will solve this differential equation using Laplace transform. As always, we start by computing the Laplace transform on the left and the Laplace transform on the right. When we compute the Laplace transform of the second derivative, we get s squared Laplace transform of y minus y of 0 times s will be minus 2s minus y prime of 0 minus 3 minus this minus 4 times, we use a parenthesis because we're going to compute the Laplace transform of the derivative, which is s times Laplace transform of y minus y of 0, and then we continue plus 20 times the Laplace transform of y equal to the Laplace transform of 64 u3 of t times sine of 2 times t minus 7. Sorry, this is u7, not u3. Then we try to solve for the Laplace transform of y. Then we have an s squared Laplace transform of y minus 4s Laplace transform of y plus 20 Laplace transform of y. And here we have minus 2s. Here I have a negative 3, and then negative 4 times negative 2 is positive 8, and then it will be plus 5. And then this is equal to, this is the Laplace transform using the formula. I get that this is e to the negative 7s Laplace transform of, we need to find the original function if this is the u7 shifting, and we see that the original is 64 times sine of 2t. Okay, now we continue solving for the Laplace transform of y. We have s squared minus 4s plus 20 Laplace transform of y. We move this to the other side and we get equal to 2s minus 5 plus e to the negative 7s times, this is 64 times 2 over x squared plus 4. Okay, and then I can divide by this expression, and I divide by s squared minus 4s, s squared minus 4s plus 20. In order to solve for the Laplace transform of y, we divide by s squared minus 4s plus 20, and we get this s squared minus 4s plus 20. And here, instead of 64 times 2, we can write 128. And then we need to compute two Laplace transform inverse. One Laplace transform inverse for this, and one Laplace transform inverse for this part. Let's start with this one. We want to compute the Laplace transform inverse of 2s minus 5 over s squared minus 4s plus 20. Then we need to decide if we have to do partial fractions of if this polynomial is irreducible. In order to do that, we complete the squares. We notice that s squared minus 4s plus 20 is equal to s squared minus 4s. Half of 4 is 2, the square is plus 4. Then I can write the 20 as 4 plus 16, and this is s minus 2 squared plus 16. We have that this is the sum of two squares, and therefore this equation doesn't have a solution in the real numbers, which means that this cannot be factored. That means that we want to look for something that looks like the right hand side of this expression, e to the 2t cosine of 4t equal to s minus 2 over s minus 2 squared plus 16, or the Laplace transform of e to the 2t sine of 4t equal to 4 over s minus 2 squared plus 16. Notice that these two, we get it from here, and the 4 is the square root of this 16. There are two ways to do this. We want to rewrite this part as a linear combination of the right hand side of these two. And one way is to rewrite the numerator. We can rewrite the numerator by saying 2 times. We want to see an s minus 2. Then we change the s by s minus 2. But we need to balance. If we do this, then we are subtracting 4. Then we have to do plus 4 minus 5 over, and I will rewrite this as s minus 2 squared plus 16. And now this is 2 times s minus 2 over s minus 2 squared plus 16, and then minus 1 over s minus 2 squared plus 16. But I don't want to have a 1 here. I want to see a 4. Then something that I can do is I can multiply by 4 and divide by 4. And that means that I can write this as the Laplace transform of 2 times e to the 2t cosine of 4t minus 1/4 e to the 2t sine of 4t. There is another way to get this 2 and negative 1/4 is by doing this. We know that we want to write this expression as a linear combination of these two. Then I just write it like this. I have to write it this like a times s minus 2 over s minus 2 squared plus 16 plus b times 4 over s minus 2 squared plus 16. Notice that the denominators are the same. Then essentially I want 2s minus 5 to be equal to a times s minus 2 plus 4b. And then we can find a and b by doing something that we do when we do partial fractions. Then we have that the coefficient of s on the right is a, and the coefficient of s on the left is 2. The constant coefficient on the right is negative 2a plus 4b, and the constant coefficient on the left is negative 5. That means that a is equal to, and if a equal 2, then we have 4b equal negative 5 plus 2a, and that means that 4b is negative 5 plus 4, and that means that b is negative 1 over 4. Then we get that this is 2 and this is negative 1/4, and we end up with the same answer. These are two ways to do this part, to compute the Laplace transform inverse of this. Then the whole thing is to rewrite this part, and we accomplished that part. Let me just erase all of this. And then we know that this is the Laplace transform of 2 times e to the 2t cosine of 4t minus 1/4 e to the 2t sine of 4t. And now we want to write the other part, this part, as e to the negative 7t, e to the negative 7s times the Laplace transform of something. We want to write something there. And in order to do that, we need to rewrite this part. We have that 128 over s squared plus 4 times s squared minus 4s plus 20. Here we have to do partial fractions, and then we can rewrite this as as plus b over s squared minus 4s plus 20 plus cs plus d over s squared plus 4. Then this is by the common denominator, which is s squared plus 4 times s squared minus 4s plus 20, and here this is as plus b times s squared plus 4 plus cs plus d times s squared minus 4s plus 20. And then we can compare coefficients. What is the coefficient of s cubed? I will get an s cubed when I do this times this, and when I do this times this, then I have coefficient of s cubed is a plus c, and on the left we don't have an s cubed. Coefficient of s squared, how do I get an s squared? I get an s squared by multiplying this with this, and by doing either this or this. Then I have a b, because I'm doing this, and then here I have a minus 4c, and then plus d, and this is equal to, there is no s squared on the left, equals 0. What is the coefficient of s? The coefficient of s, I have an s when I multiply this with this, I have a 4a, and here I get an s when I multiply this with this, plus 20c. What else? How can I get an s? When I multiply this with this, minus 4d, and there is no other way to get an s. And I want this to be, there is no s on the left, there is 0. And what is the constant coefficient? Here I get a constant coefficient by doing this, 4b. And then this with this, plus 20b. And we want this to be equal to the constant coefficient on the left, which is 128. Let's check something. Here we have 1, 2 times 1, 2. We have 4 terms here, and we have 1, 2 times 1, 2, 3. We have 6 terms. Altogether, we must have 10 terms. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then that means that we have considered all the terms. And then we need to solve this system. We can see that the solution of the system is a equal negative 8 over 5, b equal 0, c equal 8 over 5, and d equal 32 over 5. That means that I can rewrite this expression using an a here of negative 8 over 5, then I get here negative a over 5s, negative 8 over 5s, and then c is 8 over 5, and d is 32 over 5. Okay, the whole thing, all this long process was just to rewrite this expression. And remember, here we want to write negative 8 over 5s over s minus 2 squared plus 16. I want to write it as a times s minus 2 over s minus 2 squared plus 16 plus b times 4 over s minus 2 squared plus 16. And if we want that, then we want to have negative 8 over 5s to be equal to a times s minus 2 plus 4b. And from here we get that a must be negative 8 over 5. And the other equation is negative 2a plus 4b. I want this to be equal to 0. That means that a is negative 8 over 5, and 4b is equal to 2 times a. 2 times a, which is 2 times negative 8 over 5, and that means that 4b is negative 16 over 5, and therefore the b is, when I divide by 4, I get negative 4 over 5. That means that we can rewrite this part as negative 8 over 5. I'm just rewriting this part, negative 8 over 5, s minus 2 over s minus 2 squared plus 16 minus 4 over 5 times 4 over s minus 2 squared plus 16. And then I continue with this part. This part is easier. I can just write it as plus 8 over 5 times s over s squared plus 4 plus 32 over 5 times 1 over s squared plus 4. But I want to have, if this is omega squared here, I want to have a 2 here, then I will write it as 632. I will write it as 16 times 2, like this. Right? Then I can see that this is the Laplace transform, this part here, which is this, is the Laplace transform of negative 8 over 5. And this is e to the 2t cosine of 4t minus 4/5. This is the Laplace transform of e to the 2t sine of 4t. I have written all of this. And then plus 8 over 5. And this is a cosine of 2t plus 16 over 5, and this is a sine of 2t. And then when I combined this expression, Laplace transform of y equal to this part, we will get that our y is going to be equal to this part, 2 times e to the 2t cosine of 4t minus 1/4 e to the 2t sine of 4t plus, and here we will have this part changes with u7 of t times, and anytime I see that t here, I have to change it with t minus 7. Then I have a negative 8 over 5 e to the 2 times t minus 7 cosine of 4 times t minus 7 minus 4/5 e to the 2 times t minus 7 sine of 4 times t minus 7, and then plus 8/5 cosine of 2 times t minus 7 plus 16 over 5 times sine of 2 times t minus 7. This is the answer to this initial value problem. And I think this is it for this video.